Welcome to This Explainer. Okay, I want you to ask yourself a serious question right off the bat. Can your enterprise data platform actually complete a business transaction? Really think about it for a second. Because for the last 20 years or so, we've poured just massive amounts of resources into centralizing our data. We've built these huge warehouses, lake houses, and shiny dashboards that are incredibly good at telling us what happened yesterday, or maybe predicting what might happen tomorrow. But here's the absolute critical gap. They completely lack the ability to safely execute a transaction in an operational system. They can give you a nice recommendation, sure, but they can't actually act on it. So today, we're exploring a massive shift in enterprise data architecture that solves this exact problem. We're going to look at how we can finally bridge that critical gap between knowing what to do and actually doing it. And we're going to do that using a really powerful new concept called the Domain Operational Data Platform, or DODP for short. Okay, let's dive right into this. We're going to deconstruct this massive enterprise IT concept across 6 quick chapters: the analytics execution gap, what a DODP actually is, the new architectural shift, separating decision from execution, the human in the loop, and finally, strategic build versus buy. Starting right off with Chapter 1, the analytics execution gap. Centralizing our data into these massive enterprise warehouses over the last couple of decades has been fantastic for historical analysis and executive reporting. But honestly, it hasn't solved our day-to-day operational execution problems. Just think about how enterprises currently handle those issues. On one hand, you have centralized data warehouses. They consolidate everything, they standardize your reporting, but they are entirely separated from execution. They literally can't post a journal entry. On the other hand, enterprises are increasingly relying on specialized SaaS applications for things like cash application or account reconciliation. Now, these apps extract your ERP data, run it through their own proprietary black box rules, show you the exceptions, and then send the result back to your ERP. The catch here, they charge you these expensive recurring subscription fees based on transactions, users, or revenue. You are essentially renting your own operational intelligence. Which brings us nicely to Chapter 2. What exactly is a DODP? So what if there was an architectural alternative, something that gave you the execution power of a SaaS app, but allowed you to actually own the intelligence yourself? Well, that is the Domain Operational Data Platform. Let's break this definition down because it's absolutely vital. A DODP is domain-bounded, meaning it focuses on one very specific business area, like accounts payable or treasury operations. It's independently deployable, but most importantly, it executes analytical logic, it manages human exceptions, and it actually invokes authorized transactions in your ERP. Listen, this is not just another domain data product that sits there waiting to be queried. This is a domain execution product. It initiates real transactions in your systems of record. There's a great quote that captures the central proposition of the entire DODP philosophy. It simply says, "Move intelligence closer to the operational decision while preserving enterprise governance and ERP transactional integrity." It's all about empowering a specific business domain, but without creating those chaotic, completely ungoverned data silos we all want to avoid. And this, right here, is what makes a DODP fundamentally different from traditional operational analytics. It manages the complete decision lifecycle. It observes operational events, interprets them, recommends an action, allows a human to review and approve, executes the transaction, and then, crucially, learns from the result. By closing this loop, the platform is taking actual responsibility for the outcome. It's not just generating a dashboard full of insights that someone else has to go act on. Let's move on to Chapter 3, the new architectural shift. We really need to understand the underlying technical philosophy that makes all of this possible today. I mean, why couldn't we do this 5 years ago? Well, this brilliantly illustrates the shift in mindset. A central data platform asks, what happened across the enterprise? It's built for those massive, petabyte-scale historical queries. A DODP, however, asks, what decision must be made right now and who must approve it? It operates on the principle that you should scale the domain, not the enterprise. You only need the working set of data required to make a specific decision, say matching a payment to an invoice, within its required response time. You simply don't need a massive distributed compute cluster running 24/7 to do that. And that approach is made possible by a completely new, incredibly lightweight technology stack. We're talking about technologies like DuckDB, which allow for embedded, in-process analytical execution. That means high-performance analytics can run directly inside a Python process or web backend, literally wherever the application lives.
MotherDuck extends this to the cloud, allowing for dual execution. Duck Lake provides an open table format using Parquet files for durable, domain-oriented storage. And finally, ERP-native interfaces, things like APIs, BAPIs, and iDocs, which are basically secure doorways into your systems. They ensure that when a decision is made, it's safely executed right back into the system of record. This entire stack changes the economics of automation completely.
All right, Chapter 4, Separating Decision from Execution. So we now arrive at arguably the most absolutely crucial design principle in operational AI, making sure a model output doesn't just become some uncontrolled wild transaction. The crucial point is that a high-confidence machine learning prediction does not automatically equal business authorization. Let's look at a typical cash application pipeline. The AI makes an analytical decision. It's, let's say, 97.8% confident a payment matches 3 invoices. But then a policy decision has to kick in, checking if auto-submission is even allowed for the specific customer. If it isn't, an approval decision requires a human to step in and confirm it. Only then does the transaction execution actually happen. These are separate, independently auditable events, and they have to be treated that way.
Because when we hit that final execution phase, well, things get real very quickly. If you're submitting a batch of 100 invoice clearings, what happens if the ERP times out? Or what if a user already manually cleared one of those invoices in the ERP 5 minutes ago? A robust DoDP acts as a highly controlled transaction initiator. Simple retry logic is just not going to cut it here.
To safely write back to the ERP, the platform has to implement some serious safeguards. It needs idempotency, so a resubmitted batch doesn't double post. It needs optimistic revalidation to check that the invoice is actually still open right before posting. It requires per-item state tracking, not just batch tracking. It absolutely must handle reconciliation and compensating actions if a rollback is needed. And it has to maintain complete lineage from the original source payload all the way down to the final business outcome. A DoDP must never ever directly manipulate ERP database tables. It always has to use supported, governed interfaces.
Chapter 5, Human in the Loop. So there is a very common misconception out there about automation. Many folks think the human element is just a temporary band-aid until the AI model gets to 100% accuracy. No way. That is dangerously wrong. In enterprise operations, human intervention is a permanent architectural feature, not a defect. Think about it. Some transactions are economically massive. Some require strict legal segregation of duties. Models will always encounter new, unseen patterns. And this golden rule really highlights why humans are essential. Every manual correction should create reusable domain intelligence. When a human overrides a model's recommendation, that feedback shouldn't just vanish into the void. It should directly update your training datasets, calibrate your model confidence, and improve your future rules. Now, what's really interesting about this is the sharp contrast in how we build tools for these humans. A traditional dashboard is passive. It just kind of sits there and tells a stressed-out user that they have 1,200 unmatched payments. It basically just admires the problem. A DoDP, however, provides a decision workstation. This is an active, operational workspace optimized to show the user the very next payment, explain exactly why the AI recommended a specific match, allow them to easily override or approve it, and then instantly capture that learning. It actually helps the user act safely and swiftly.
Finally, Chapter 6, Strategic Build versus Buy.
Okay, we've talked a lot about the architecture, but what about the business strategy? When does an enterprise architecture team choose to build a DoDP versus just going out and buying another SaaS product? Well, this decision framework is exactly what CIOs and enterprise architects need to be using. You favor building your own DoDP when the process offers high strategic differentiation, when the recurring SaaS cost is painfully high, when your internal process is highly unique, and crucially, when you have strong internal domain expertise. Actually, scratch that, especially when you have strong internal domain expertise. If it's a completely standardized process that gives you zero competitive edge and the SaaS vendor is cheap, just buy the SaaS. But for your core operational intelligence, owning your domain automation is rapidly becoming a strategic imperative. Now, the source material makes a wildly fascinating claim here. Using this lightweight tech stack, you can potentially reproduce 90% of a SaaS product's core value at a fraction of the cost over a 5-year horizon. But let's pause here for a second. The architecture clearly warns that this is a business hypothesis, not a proven architectural fact. The underlying compute might be cheap, sure, but building a real product requires intense discipline. Why? Because mature SaaS products, they have serious hidden depth. It's not just about spinning up a machine learning model.
It's all the localized country rules, the complex workflow variants, the security and audit logging, the wild edge case integrations, and the heavy operational burden of handling upgrades. An inexpensive architecture definitely does not automatically mean an inexpensive product. This is exactly why a hybrid strategy, keeping SAS for those highly standardized peripheral tasks while building DoDPs for your high-value decision layers, is very often the smartest route.
Let's move to and see how this builds into a logical 7-step delivery roadmap. You don't try to automate the whole shebang on day one. You start with phase 1, observe the domain, but without writing anything back to the ERP. Phase 2, make recommendations but require manual execution. Phase 3, assist the user with a heavily controlled UI. Only in Phase 4 do you actually turn on automation for highly confident, policy-clear transactions. From there, you continuously learn, federate your governed data products back out to the enterprise, and finally, replicate this reusable platform foundation across other domains. You build the foundation once, and you reuse it for payables, for treasury, and way beyond.
Which brings us to our final thought. The real breakthrough of the DoDP isn't just swapping out databases. It is a fundamental shift in responsibility. If you're going to leverage AI to make real business decisions, you have to ask, is your data platform just a passive information layer, or is it actually ready to safely govern the final mile of business execution? It's time to stop just observing your business and start safely executing it. Thanks so much for joining me on this explainer. Keep questioning your architecture, and I'll catch you on the next one.